Could a solar storm ever destroy Earth? Our planet has one huge advantage in the fight against space weather. All life on Earth owes its existence to the sun's radiant heat, but what happens when that radiation surges out of control and billions of tons of charged solar material suddenly barrel our way at thousands of miles a second? What happens when Earth takes a direct hit from a solar flare, and could a strong enough one be strong enough to destroy life on our planet as we know it? The answers are complicated, but the most scientists agree on one thing: Earth's magnetic field and insulating atmosphere keep us extremely well protected from even the most powerful solar outbursts. While solar storms can tamper with radio and radar systems or knock satellites offline, the most harmful radiation is sopped up by the sky long before it reaches human skin. We live on a planet with a very thick atmosphere, and that stops all of the harmful radiation that is produced in a solar flare. This is what Alex Young said, Associate Director for Science in the Heliophysics Science Division at NASA's Goddard Space Flight Center in Greenbelt, Maryland. He said, even in the largest events that we've seen in the past 10,000 years, we see that the effect is not enough to damage the atmosphere such that we are no longer protected. This is what Young said in a 2011 video addressing fears that a solar flare would end the world in 2012. Still, not all solar flares are harmless. While Earth's magnetic field prevents widespread death from solar radiation, the sheer electromagnetic power of a flare could disrupt power grids, internet connections, and other communication devices on Earth, resulting in chaos and potentially even death. Space weather experts at NASA and other agencies take this threat seriously and closely monitor the sun for potentially hazardous activity. What are solar flares? Solar flares occur when the sun's magnetic field lines become taut and twisted, causing enormous planet-sized storms of electromagnetic energy to form on the sun's surface. We can see these storms as cold, dark splotches known as sunspots, and around sunspots, huge tendrils of magnetic field lines twist, spool, and sometimes snap, creating powerful flashes of energy or solar flares. Most energy from a solar flare is radiated away as ultraviolet and X-ray light. Live Science previously reported, however, the intense energy of a flare can also heat up nearby gas in the sun's atmosphere, launching enormous blobs of charged particles known as coronal mass ejections, or CMEs, out into space. If a flaring sunspot happens to be facing our Earth, then any resulting CMEs blast right towards us, typically reaching our planet in anywhere from 15 hours to several days. Whether or not you've heard of CMEs, you likely have lived through hundreds of them. The sun emits anywhere from 1 CME each week to several a day, depending on where we are on the sun's 11-year cycle of activity, according to NASA. Most CMEs pass over our planet completely undetected by the general public thanks to Earth's powerful magnetic field, or our magnetosphere as we call it. However, the biggest, most energetic CMEs can actually compress our planet's magnetic field as they pass, resulting in what's known as geomagnetic storm. As electromagnetic energy from the sun pours into our magnetosphere, atoms and molecules in Earth's atmosphere become electrically charged, creating effects that can be seen around the world. And during such storms, the aurora borealis and northern lights, typically only seen near the North Pole, can shift down so far that it becomes visible near the equator. Radio and radar systems around the world can black out, and electrical grids may become overloaded and lose power. Some experts fear that a sufficiently large CME could create an internet apocalypse by overloading undersea internet cables and leaving part of the world without web access for weeks or months, though this has not happened yet. Satellites and space stations which orbit beyond the protection of Earth's atmosphere can also be debilitated by the renegade radiation of CMEs. Still, even the most powerful geomagnetic storm in recorded history, the 1859 Carrington event, had no noticeable impact on the health of humans or other life on Earth. If even stronger solar storms battered our planet before this, there's no evidence that they impacted human health either. No matter what, flares do not have a significant effect on us here on Earth. Doug Biesecker, researcher at National Oceanic and Atmospheric Administration Space Weather Prediction Center, said, what sort of fluxes would have to strike the Earth to wipe us out? I don't know the answer to that, but obviously we've never even observed a solar event big enough to have any measurable effects on human health. Star damage. Our nearest star may not pose an extinction threat, but scientists suspect that other nearby stars could. When certain stars run out of fuel and die, they explode in a tremendous supernova that blasts powerful radiation into space for millions of light years around. These blasts are many, many times more powerful than solar flares. Should such an explosion occur sufficiently close to our Earth, the dying star could bathe our planet in so much ultraviolet radiation that it strips our protective ozone layer away, making Earth vulnerable to a barrage of charged interstellar particles. The authors of the recent study published all the proceedings of the National Academy of Science in August 2020 suspect that the death of a star within 65 light years of Earth may have done just that about 359 million years ago, at the end of the Devonian period, 416 million to 358 million years ago. A mass extinction at the end of this period resulted in the death of 70% of the Earth's invertebrates, though scientists are not certain what triggered it. However, an examination of fossil spores from the time of the extinction revealed signs of ultraviolet light damage, suggesting that perhaps an exploding star triggered that extinction. Fortunately, there are no supernova candidates close enough to our Earth to pose such a threat anytime soon, the study authors reassured. We have only our warm little sun to worry about, and our atmosphere makes sure that we stay on that star's friendly side. This is by Barrington Spector on Live Science. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.